Okay, team, the last lesson here on linear approximation is actually a lesson just about using derivatives to estimate in general. So you're going to see two types of tables problems in this lesson. The first is like problem number, we'll call it number 1 here. So notice I am given the rate at which the temperature of an object is changing. So in problem number 1, I'm given the derivative in the table, right? So L of t is a derivative. And it gives me a point, and it says use a linear approximation to estimate the temperature. So given a derivative in these types of problems, we estimate a value of the original function. Okay, so given the derivative, we estimate the value of the original function, and we do that using a linear approximation. And then it's important to understand the difference between the two. So in problem number 2 here, so you can take a second to read it. In problem number 2, s is position. So we know s is like our original function. And we want to use the values of the table to estimate s prime of 4. So here in problem number 2, we're given our original function, and we're estimating the derivative. And we're doing that using something we're really familiar with. We're using a secant line. Okay. So these types of tables problems are really common in the AP exam. We'll do one of both here in succession, but you actually already know enough to solve each of these. So we'll look at our linear approximations problem first. Okay, so what we need here is a tangent line, right? To find a line, you always need a point and a slope. And it says use a linear approximation when t equals 18. Remember, L of t is the derivative, right? So t equals 18. L of 18 is 2, which is the slope of my tangent line. And we know that L of t is a derivative is because it's the rate at which the temperature of an object is changing. Okay. All right. And what we also need is the point, right? And the point is given to us in the text. The temperature of the object when t equals 18 is 41 degrees Fahrenheit. So our point time is x, right? So 18 comma 41. And then our tangent line would be point slope form, y minus 41 equals 2 times t, I should say t minus 18. I can isolate y. So we'll say 2 times t minus 18 plus 41. And then remember, I'm looking for the temperature at t equals 17.9. So I'll plug that in. And when you type this into your calculator, you get 40.8. And then the units are important, right? So remember, we're estimating the temperature of an object at a specific time. So your options are like degrees per minute or just plain old degrees. Because this is a temperature at a specific time, this is just going to be plain old degrees Fahrenheit. So it's the derivative that gets those units. Okay. Let's try the secant line and hopefully we'll be clear on the difference. All right, in this example, remember s of t is position and s prime of t is going to be velocity, right? It's going to be the derivative of position. And we are trying to estimate s prime of 4. Okay. So all we have to do is figure out where in the table t equals 4 lives. And it's going to be between 3 and 5, right? So t equals 4 would be here. So remember, this is some kind of curve. I want the secant line between 3 and 5 to estimate the derivative in the middle there, right? So this is going to look like this. S of 5 minus s of 3 over 5 minus 3. So that's our kind of rate of change slope formula that we've always been using, right? And then I just pull these values out of the table, so that's going to be 34 minus 24. 5 minus 3 is 2, which gives me 10 over 2, which gives me 5. Okay. And now units are important too, right? So this is a velocity, so it's going to get meters per second. Okay. So the derivatives problems where we're estimating a derivative are always going to have some kind of unit rate in the solution.